Hey guys, welcome back to the channel. This footage is from, I think, about 2 years ago. This actually might have been right at the height of the pandemic when this homeowner was selling his house in Westfield. And as you can see, it's a lot of components and not a lot has been updated over the years. But what we have here is a 200 amp main breaker enclosure, which is that right there, which travels into the current transformer box, a CT box. Right to my right there. The trouble with this panel, as you can see, is there's way too many circuits in a panel that's only rated for 40 or maybe even 30 in this panel. I don't totally remember, but I believe there was about 62 circuits in this panel when it was only rated for 30 or 40. I don't remember the specifics, like I said. So we're here to change out this panel, and that's what we're going to do. Another good reason to change out this panel is this particular Murray with the red main breaker. It's a 200 amp panel. They've been known for failure, especially once you turn that main breaker off, you can't turn it back on. I've seen this more than once over the course of my career, so changing out this panel was a good thing. Now that conduit up on the top there feeds another sub panel over there to the left. I believe it was 100 amps. I doubt highly that it was ever inspected just because of the workmanship of that conduit. But I wasn't there to upgrade that. I was just trying to make this panel safer without more circuits than was rated for the panel. That's always an important thing. And that'll tell all the information you need to know is right there when you open up the panel door. You could tell how many circuits you can put in, and what the capacity is, or where, if you're allowed to put in twin circuit breakers, where on that bus bar you're allowed to do that. So that's pretty important. If you don't know how to read that, then I would definitely tell you to contact a licensed electrician to do that for you. The trouble with all these circuits in this panel is the bus bar is going to be overloaded. It's going to be working harder than it was rated to work for. So that's why we're there changing it. I want to say this took me, boy, I got there early in the morning and I was there till late at night. But you're going to see most of this work here today. So as you can see here, I have a double pole circuit. All right, so they never identified that white conductor, which by code needs to be re-identified as a hot conductor. Anything but green, gray, or white, it would be acceptable. And the other two wires you see below there with the red tape. So what I'm doing is I'm taping the two conductors together that make up the double pole circuit. So when I take these cables out of this panel, I know what they are when they go back into the new panel, and they'll get a double pole breaker. Best advice I can offer when working on a job of this magnitude with this many conductors and this many circuits is to just go slowly. Oftentimes in these old panels, they might have a couple wires tied together with wire nuts, not just to extend the circuit, but to maybe bridge to another circuit or to a switch. So take your time when working with a panel like this. The first order of business, as with any panel change, is to undo my ungrounded conductors, which I've done here. I've disconnected from the breakers. Now I'm able to loosen up the screws that hold this bus bar assembly and the main breaker assembly, and I'm able to disconnect it from the enclosure, which is going to give me more space to undo all my neutral conductors and all my grounding conductors. As you can see, I'm struggling here to get this out. I don't know if there's a screw. Oh, there's one more screw there at the bottom that I have to undo. And then, of course, I'll cut the ungrounded conductors when I get a moment here. And as you can see on the bottom, there's a wiring trough, which is where this wiring goes through, and it feeds a couple other things here. I didn't get too involved in any of it. I was just there to change this one panel, and I just reused these service entrance conductors, or rather, these are feeders at this point. Once you leave that main breaker, downstream from there, everything feeding other panels will be known as feeders. That's how it's defined by the NEC anyway. So I do this often when I'm putting these new panels in, is I just get a rough idea of where I want it to sit. All right, my biggest challenge right here is that 1.25" EMT coming into the left there for that sub panel. I got to get it back inside this enclosure, and I obviously got to get that bottom nipple into the bottom of the enclosure as well. So right here, what I'm doing is a rough idea, and I believe I take a, probably take a Sharpie here and just do a rough measurement before I make my cutouts with my my punch kit. Yep, looks like that's exactly what I did. As you can see, I have those green ground bars on either side because we want to isolate our grounds and neutrals in this panel, being that it is a main lug only panel. So what I'm going to do is I'm going to get a rough idea of where that 2-inch knockout's going to be. I don't know if I stay right there. I just go down the middle here. Okay, that would work. And then I do the same thing right here as I get an idea where that middle knockout's going to be. Make my knockouts and then get the enclosure in. So once you get the enclosure in, then you start working with the branch circuits, getting those in. Oftentimes when you're working in a big house, it's a long walk back to the truck. Fortunately, I was able to park in this guy's driveway because he had a 2-car driveway. But I had to go up these stairs, obviously, down this hallway and through a garage. And it wasn't too bad, but you got to be careful you don't, mark up any of the walls or mark up any of the floors. And of course, you got to close this door. I think it was in the summertime too, so I had to make sure that door was closed. So you don't want to bump, you don't want to scratch the Jaguar. So all of that's involved with this job as well. I really would have liked to have shown you how I got that enclosure in and how I made the knockouts, but I'm looking back at my footage here and I don't have it. So that tells me I didn't hit record, and that's not the first time that's happened. So I apologize. I really wanted to show that to you, but obviously I got it in, made those knockouts with those lines that I made, that I showed you with the Sharpie that I showed you in the previous clip. So now I'm ready to start putting my circuits in, and I'm figuring out what I want to go in first, what's going to go in the back of this enclosure, what's going to go in the front. All right, so when I can, I like to use these double BX connectors, we call them. You can use them for the Romex, the non-metallic sheath cable as well, as you see here. I like to use these heavy-duty connectors. I guess you want to call them heavy-duty. They're not called heavy-duty. They're just called double BX connectors. I like to use these when I'm working with panels that are mounted on the surface like this, where you can see the connector. I can use the black button connectors here too, and occasionally I will use those if everything's Romex maybe. But here we have BX, we have a lot of armored cable, and we have the non-metallic sheath cable mix. So what I like to do is I like to put the cables inside the connector and then get the connector seated in the spot. And then I'll come back with the lock nut, obviously, and tighten up this lock nut now, because you won't be able to do it later if you put all the other home runs in the box here. Make sure that's nice and tight. I have a light here. I've since started using a headband. I like to use the headlight now rather than this light. In fact, I haven't seen that light probably since this job. I might have lost it there. So get that connector on, and then once your wires look neat, you've got your wires inside this enclosure the way you want them. Just take your time doing this and make it look nice. Now I'll come back with the strap and tighten it down and on to the next one. And basically that's what I got to do for the rest of the circuits that you see hanging outside this box. Okay, so now I'm on to these armored cables is what they're called. The term BX, it's not found in the National Electric Code, so you can look for BX cable in there. You will not find it. The term BX cable originated from the manufacturer who first built it. Maybe not the first people that manufactured it, but it used to come to areas like where I live in New Jersey in a wooden crate marked BX Cable Company, which stood for Bronx Cable Company. Here I'm using Greenlee BX cutters. Okay, that's a term that pretty much everybody knows, BX, and I still call it BX, but the real term is armored cable. And so what you'll do there, actually, that's MC cable, not even BX cable or armored cable. I hope you're not confused. MC cable is a cable that actually has an insulated equipment grounding conductor, that green conductor. That's how you know it's MC cable. Armored cable, aka BX cable, will not have that insulated ground, and the outer sheathing acts as the equipment grounding conductor. But anyway, I'm using my Greenlee connectors, my strippers here. And what you do is you feed that in, you tighten down that knob. It cuts the BX to an area just enough to break the sheathing away from the conductor without nicking the conductor. And I highly suggest you get one of these if you're going to be doing a lot of this work. Sure, with the MC cable, you could use a pair of diagonal cutters, or we call them dikes in the field. But that's definitely not advisable. So this one's a BX cable, and you see I'm putting what's known as a red head. That's known as the real term is an anti-short. And what that does is it safeguards that sharp cut that you just made with the cutters from nicking the conductors. The armored cable, you are required to put the anti-short, aka the red head, around the conductors on armored cable. For MC cable, it's not required, but I highly suggest that you put them in when you can. Okay, so if you're here and you're not an electrician, or maybe you're an electrician just getting started, this is how you use the BX cutters right here. You put the cable inside this little tray, and as you can see, I have a knob that I'm tightening down with my right hand. And I'm tightening that down, that little tooth that sticks in there. Tighten it down until it's firm, and then you're going to grab the crank and hold the cable in there and crank it before breaking the seal on the sheathing. And that's how you strip a piece of BX. Once you have the sheathing removed from the cable, you come back and you install these anti-short red heads, and you slide it up inside the cable and use this wraparound wire here that comes with the BX to attach the red head to the cable so it doesn't fall out of there. And you just wrap it around the BX cable before putting on the connector. Next step is to put both of these cables into the connector and slide the connector up into position and tighten it down. Now it's important you get a nice, that you tighten it down pretty hard around this BX cable, because that actually completes the equipment grounding path once you attach it with the lock nut to the enclosure. So make sure you get a nice tight fit here. You don't want to break the cable, but you want to make sure it's nice and tight because it serves a purpose. Then you can slide your cables and the connector into the enclosure before sliding the lock nut up the wires or the conductors and make a nice tight fit into the enclosure. Now you have two circuits that are properly grounded to the enclosure. This is very, very important. Grounding clears any kind of ground fault. If it's not properly grounded, then you could have a fault and it won't be able to clear itself. The last step in this process is to tighten that lock nut. I'm using a flathead screwdriver and my lineman pliers to accomplish that. Now that I have most of my branch circuits in this enclosure, what I'm going to start doing is I'm going to start peeling away the paper that's around these BX cables, which is standard. And then, of course, we will slice the sheathing off of the Romex cables as well. So just take your time with this, make these wires nice and neat. Usually what I do right after this is we'll start separating our grounds and neutrals and our hots and prepare to start terminating these conductors in the enclosure. If you take your time here, you'll have a nice, neat product when you're done. So go ahead and take your time and do a nice job. Just look at this mess. Would you believe this mess? All these conductors. So it's definitely a challenge, and you know, I'm just one person. I was definitely here all day, that's for sure. And I was probably pulling away when it was dark out. I believe this was in the summertime. Anyhow, I was down in the basement and the air conditioning on, so it was nice and cool. Obviously, the power's not on, but the air conditioning was on the whole time I was there, so it wasn't so bad. But just look at all these conductors. It could be overwhelming, but if you just do one at a time, you'll eventually get there. Obviously, some of these circuits had labels on them already, so I'm putting those labels back on. That's what that's for. So when they put them under the breaker, we're able to label them later on. Labeling this panel took a lot, but I believe a lot of them were already previously labeled pretty well, believe it or not. So that wasn't as big a challenge as I thought it might be. Going forward here, it's just one conductor at a time. Try to do it nice and neat as possible and get to the end. Just don't give up, just keep going. Exposing a conductor does not have to be difficult for a number 4 copper wire. What we're looking to do is take a utility knife and score around where you want to open up the insulation, expose the conductor, which is about a 1/4 inch or so. And now you want to split it down the middle here. Again, you just want to score it. Once you're done scoring it, if you have a nice sharp knife, nice sharp blade, just take your lineman pliers and just peel off the rest. The reason why we want to be careful is we don't want to nick the conductors if we can avoid that from happening. I was here for a lot of hours on this day. I just remember it was a couple years ago, like I said. So get that 100 amp double pole circuit breaker. Sometimes that could be a pain in the neck getting those in. Because the conductors are so thick, you have to pre-bend them so you can plug the new circuit breaker in. So I'm a real proponent, that's not the word I'm looking for. I'm a real fan of identifying my conductors. So even though that conductor is white already, I'm putting new tape around it to re-identify it so that there's no doubt that that's a neutral conductor. Okay? The code actually does call for that, and I kind of cringe when I see other electricians just put one little piece of tape around there and say, that's it, it's identified. And some inspectors would be okay with that. If I was an inspector, I would want more identification. I want that conductor to be completely identified. Okay? So again, we just scored this 2/0 copper here and peeled it away. we tightened down our Allen wrench kit. I think that's a 5/16 drive, maybe a 1/4 inch there. Anyway, that's the last step before energizing that main breaker. And so now that the main breaker is on, I'm going to verify my voltage between both of my hot legs, and I have 245 volts and I have 122 to each leg, which is exactly what I'm supposed to have. Before I go, I want to identify all this equipment. That's the main disconnect. That's the utility meter. That's the utility current transformer box. And then I just got to take the knockouts out of the panel cover and put the panel cover on, and we'll be ready to go. If you have any questions about this installation, guys, leave them down in the comments. And as always, thanks for watching these videos. We'll see you soon. See you on the next one. Thanks for watching this video. Be sure to subscribe, and we'll see you on the next one.